It's on. So today we're supposed to do analyzing graphs, part 1, right?
Yep.
We're supposed to do analyzing graphs, part 2, part 1 today.
Yeah.
So let me see. Because we have to watch a video. If I turn on, I'll show the video. Looks like we're supposed to watch the video. So,
all right, let's put everything we've learned about derivatives together to analyze the graph of x cubed plus 2x squared minus 15x. In order to do that, I need to know the domain, x and y intercepts perhaps. I certainly need to know the first derivative and the critical points so that I can figure out where the graph is increasing and decreasing, if I have any maxes or mins. And I need the second derivative to help me find possible inflection points and concavity. Then we're going to put all that information together on a graph. So first, this is a cubic function. That means its domain is from negative infinity to positive infinity. And its x-intercepts will be found where the y is equal to 0. So let's set y equal to 0 and solve for x. I can factor out an x. I'm left with x squared plus 2x minus 15, and I'll bet that factors. We'll have x plus 5 and x minus 3. Let's check and make sure we've factored it correctly. X times x will give me x squared, plus 5x minus 3x will give me 2x, and plus 5 minus times negative 3 is negative 15. All right, so if three things are multiplied together and they equal 0, one of them has to equal 0. Either x equals 0, or x plus 5 equals 0, or x minus 3 equals 0. And so my x-intercepts are at 0, 5, negative 5, and 3. Y-intercepts happen when my x is 0, so I'll get x 0 cubed plus 2 0 squared minus 15 times 0, and that's just equal to 0. Okay, let's take the first derivative. My first derivative will be 3x squared plus 4x minus 15. And I will set that equal to 0 in order to find any critical points. So 3x squared plus 4x minus 15, set it equal to 0. Let's see if we can factor it. Well, 3x times x would give me 3x squared. 3 times 5 would give me 15. So let's see, if I put the 3 here and the 5 here and made this a plus and this a minus, let's check. 3x times x is 3x squared. Positive 9x minus 5x is positive 4x, and negative 5 times 3 is negative 15. All right. If they apply together and they equal 0, one of them has to be 0. Either 3x minus 5 has to be 0, or x plus 3 has to be 0. So x is 5/3, or x is negative 3. Now these are critical points. We don't know if they're maxes or mins, though, until we make a first derivative chart. So let's do that. Let's mark these points on my first derivative line. How about negative 3 and 5/3 right there? We know that the derivative at both of those x values, I don't know why I put a 0 there. That should be an x. We know that the derivative is 0 at both of those x values. So how about if we pick negative 4 and 0 and 3 to test? I'm going to plug into the factored form because that makes it easier to calculate the sign of the derivative. I don't need to know what the actual number is. I just need to know whether the derivative is positive or negative. So if I plug negative 4 into this factor, I'll have 12 minus 5, that's positive. Oh, sorry, negative 4. Negative 12 minus 5 is negative. And if I plug negative 4 into x plus 3, I will also get a negative. A negative times a negative is a positive. If I plug 0 in, 3 times 0 minus 5 is negative. And if I plug 0 in here, 0 plus 3 is positive. A negative times a positive is a negative. And let's see, 3, I'm plugging in 3. If I plug 3 in, 9 minus 5 is positive. If I plug 3 in, I get another positive. A positive times a positive is positive. So now let's check these out. The signs are changing, so these critical points must be extrema. This one goes from increasing to 0 to decreasing, means negative 3 is a max. And my graph here goes from negative to positive, means that 5/3 is a min. All right. And we can see where the graph is increasing and decreasing. Let's take the second derivative. We'll get 6x plus 4. For our second derivative, we'll set that equal to 0 to find our possible inflection points. So if we solve for x, we have a possible inflection point. We don't know it's an inflection point until we check it with the second derivative. So if I plug negative 2/3 into the second derivative, I get 0. Let's try negative 1 and 0. I plug negative 1 into the second derivative. Negative 1 will give me a negative. If I plug 0 in, I have a positive. And so, yes, the sign changed. That means negative 2/3 is an inflection point. All right, so now I'm ready to put all this information together on one graph. But before I do that, I will need the y values for these various points that I need to mark on my graph. So my x-intercepts, 0, 0, negative 5, 0, and 3, 0, and my y-intercept is 0. I have a max at negative 3. If x is negative 3, I plug x negative 3 back into the original equation to find out that negative 3, the y value is 36. 5/3, if I plug 5/3 back into the original function, I see that the y value is negative 14.8. And if I plug negative 2/3 into the original function to find the y value, I find that that y value is about 10.6. All right, so let's graph this thing. My axes are going to have different measurements on them. My x's are all between positive 5 and negative 5. 5, 6. So we'll just go from negative 6 to positive 6. My y's, though, range from about negative 20 to 40. So let's do 10 for each of these ticks. 10, 20, 30, 40. Okay, first of all, let's mark these points. We've got 0, 0, negative 5, 0, 3, 0. Those are our x-intercepts. We have negative 3 and positive 36. So negative 3 and 36 about here. 5/3 is 1 and 2/3, so about here, and negative 14, negative 15, somewhere about here. And negative 2/3 is about here, and 10.6, so right about here. All right, I know that this guy is a max, and I know that this guy is a min, and I know that this guy is an inflection point. I know that my graph is concave down from negative 2/3 till negative infinity, so it's going to be shaped concave down like a frown. It's got to go through this point, negative 5/3, and be concave down. It's concave up from negative 2/3 on, so it's going to be shaped like a cup. It's got to hit that x-intercept, and it's got to, whoops, hit this one. There. All right, and there we have the graph. Let's check our increasing and decreasing information. The graph is increasing until I get to -3, x equal -3. It should be decreasing until I get to positive 5/3, and then it should be increasing again. And it is. Great, we did it.
So do you want to solve the paper and then come back?
That's all that's on the agenda for today, right?
Yep. So do you want to solve it together, or I don't know what to do.
Yeah, sure. I don't know how, it's a little bit tricky to explain.
I mean,
And some of them are actually kind of hard.
I know how to do it, but I don't know what we have to discuss because it's basically solve the questions that she explained, right?
Yeah.
So Sam,
Yeah.
do you have any question or do you want to go through it together? Because I understand, but I didn't know she wants us to discuss everything or
No, we're just supposed to, I guess we just go through the problems together and we're supposed to talk
all.
about any questions about it.
You mean all of them, 1 through 4?
What?
Yeah.
I couldn't hear what you said. It was having a little bit of
There's
problem.
problem 1 through 4. Do you want to go through every questions, or do you want to just see number 1?
Well, it would take a while to get through all these, so
Right.
let's do the first one.
Okay. So for the domain for this equation will be parenthesis negative infinity comma infinity parenthesis, right?
Yeah, because it's a polynomial, so it
Right.
domain from negative infinity to infinity.
Mm-hmm. Did you solve the x-intercept? Or not yet?
What?
Did you solve the next one, the x-intercept?
You gotta set the equation equal to 0,
Mm-hmm.
and then you gotta solve it.
You solved it?
Yeah.
Or are you working on it?
No, I solved it.
Okay. So I got 0 and -6 plus minus root 96 over 2.
Yeah, that's what I got. But the you can simplify it a little bit. The
Um,
second one, you can simplify to like, yeah, I got -3 plus minus 2 times the square root of 6.
2 times square root of 6. You say 2 or 12?
2.
2? So if you do b squared negative 4ac, it would be root 96, right?
Yeah.
So it will be 6 root 15, wouldn't be? Wait, Um, 16, 12. So I think the answer could be -3 plus minus 6 root 15.
I got -3 plus minus 2 root 6.
Would it be? I don't know, did you hear me?
Yeah.
Yeah. So the x is 0 and -3 plus minus 6 root 15.
Oh, I don't know. I can't I'm not really sure what you did. I got because I got -3 plus minus 2 root 6.
Well, so if you do the formula -b plus minus root b squared -4ac, the b squared minus 4ac will be root 96, right?
Yeah, I think so. Let me check. Okay, so, negative. Oh wait, it's right here. So I did that quadratic formula and gets negative 6 plus minus the square root of 96 over 2. Is that what you got, or did you get something different?
I got 4 over 6. Negative 6 plus minus root 96 over 2.
Yeah, and then
And if you I don't know how to explain. If you divide by 4, the 96, it comes out 4 and 24. And you can divide by 24 as 4 again. It will be 4 and 6. So it will be 4 root 6, right? So you're sorry. You are right. So I'm sorry. I was.
Yeah, that would be 4 root 6, and then
Yeah.
and then you can factor out the 2, and then you would have negative 3 plus minus the square root of 24.
Right. You're right.
All right, so that means our x-intercepts are now you can actually simplify the 24 again.
Mm-hmm.
And then you would have 2 root 6.
Right.
So yeah, those are our x-intercepts. It's negative 3 minus 2 root 6, 0, and negative 3 plus 2 root 6.
Yeah.
Right?
Yep. That's right. And the y-intercepts will be 0, right?
Yeah.
Okay. And the first derivative is 12x squared plus 48x minus 60.
Yeah.
Critical points. Did you get the critical points?
What?
Did you get the critical points?
Oh, yeah.
What did you get?
I got negative 5, 400, and 1 negative 32. So, yeah, the x values is negative 5 and 1.
Yep.
All right, and then you need to do that first derivative chart thing.
Mm.
Kind of tell which one's which. So did you get it?
Yep.
All right. So we have that the negative when x is -5, that's the min,
Mhm.
and x is 1 is the max.
Right.
All right. So then we need to find the second derivative.
The second derivative will be 24x plus 48, right?
Yep, that's what I got.
Okay.
And then we solve that and we should get x equals -2.
Uh-huh.
All right. So we need to do that second derivative chart thing.
Mhm.
We should get that it is an inflection point.
Mhm. At -2.
All right. So now we should have a bunch of now we should be able to get a whole bunch of points that we need.
So we can use -5 and 400 points, and the 1 and -32.
Yeah, you should plug in all the critical points. All the x values for the points that we got.
Right. 1, 2,
All right. So did you get all the points?
Yep.
All right. So now it's kind of hard to show these, but you should be able to draw it with those. Pretty good.
So do you want me to show you?
Yeah, sure. Maybe a little hard to see though.
Looks like this. I'm not sure.
Yep, looks a lot like what I got.
Yep.
So I think we're good there.
Yeah, I think we're great.
Just to warn you though, the other ones they get a little more tricky. Here.
Yeah. It looks like it, like number 2, number 4. So do you want to go through other numbers too?
What?
You want to go through other problems, other questions?
We can if you want, but I think we're probably fine. Do you want to go over different ones?
What did you say, Joseph? Did you solve the internet problem? I'm not sure if he's in or not.
Huh, I could hear him for a second.
Right. Well, since we didn't start with the pray, if Joseph comes back, I think he can pray for the close part. What do you think?
Yeah, if you can make it. So, do you want to work through any other ones, or?
I don't know. What do you think?
Well,
Because I
we
feel
have been here for almost an hour.
right. I'm comfortable for doing. So it's kind of. I think we should.
So, is there a specific one that you want to do?
Um. What about you?
So you want to do the third one then?
Do I want to do what?
Oh, do you want to do the third one?
The third one?
Yeah.
Sure.
All right.
So this one also, the domain will be same as number 1, right?
Yeah.
Okay. Did you get the x-intercepts, y-intercepts?
Yeah. I just got 0, 0 for both.
Right. What about
Right. And then we find the first derivative.
uh-huh.
So then we need to find the first derivative.
I got x, e, and with a small x plus e with a small x.
Uh, yeah, that's what I got too.
What about the critical points?
Yeah, I got those. I got that. There's one.
1.
The critical point is at -1.
Uh-huh. -1 point, -1 and negative 0.37. 37.
Yep.
And you know how to do the chart part, right?
Yeah.
So did you get the second derivative?
Yeah. I
Yeah.
got xe to the x and 2e to the x. No, plus 2e. Xe to the x plus 2e to the x.
I think that's what I got too.
And we solve that one for 0.
I got -2 and negative 0.27.
Yep. That's what I got too.
Yeah, so for the first chart will be the -1 is the minimum.
Yeah.
And for the second chart will be the -2 is in something point.
Inflection point.
Yeah.
Yeah, that's what I got.
Okay. So now for the graph. Mm,
Huh.
did you draw the graph too?
Yeah.
Does it look like this?
Yeah, that's what it looks like.
Okay.
I could show you it. I think you'll see it backwards. So.
That looks like mine. It's pretty. It pretty looks same.
Yeah, my screen stuff is showed shows everything flipped around. It's weird.
Mine too.
It must only show it flipped around on our end then, because the BYUI on your shirt is words.
Oh, that's true. That's weird.
So that's weird. I didn't know I did that.
Oh, is that all? I guess he's not gonna come back.
Yeah, I think he couldn't get his internet to work.
Alright. I guess we're the only two who made it for today.
Yep.
Do you want to do the closing pray?
I'm sure. Yeah, I'll do the closing since you're gonna do the opening.
Okay, thank you.
Yeah. Heavenly Father, thank you for this day. Thank you that we could meet with each other and go over the math, and that we were able to gain a better understanding of it. Please bless that we will do well in the remainder of this semester, and we say these things in the name of Jesus Christ. Amen.
Amen. Thank you.
All right. Well, I guess I'll see you next week.
I'll put the link on the email.
Okay.
See you next week. Have a good week.
You too.